Okay, so we have this PDF here, right? And what I'll do is kind of show you how we go from the PDF to the CDF. So let's say we have a probability density function on some interval AB, right? The cumulative density function, you could think of it as the integral of the probability density function, and I'll just put a dummy variable. So instead of x, I put t, between x and let's go minus infinity here. This is the definition of our CDF. So when we integrate the function on this range a to b, in this example, a is 0, b is 3, right? So when we integrate on this range, we are integrating this piece of the function here. But what we need to remember is two important properties. If we take the limit as x approaches minus infinity of f of x, we get 0. And if we take the limit as x approaches positive infinity of f of x, we get 1. And these two things are important because when they say give the full definition of the CDF, we need to include sort of the outlier values, right? So these values here, what happens outside of our range? So let's look at the CDF, right? So f of x is the integral with minus infinity 2 on 15 4 minus dummy variable dt. The reason for the dummy variable is because we substitute an x, right? So if we substitute x into x, that's kind of weird. So we're just going to substitute it in the dummy variable. This should be 40 minus a half t squared between x and minus infinity. I think sometimes in the definition, you will see this being a. So instead of minus infinity is a. And the reason that works is because in this case, a is 0. So it gives the same effect as minus infinity, right? Because that whole difference just going to be 0. So it doesn't really change the value, right? So I think here we just get 2 on 15 uh, 4x minus a half x squared, right? If we take out x, we're left with 4 minus a half x. Or what we could do, we could actually take out 4 2 on 15 times 4x. And over here, we're left with 1 minus, what times 4 will give us minus a half? Well, that is minus 1 over 8x. So if we actually expand this bracket back out, we're going to get our original bracket over here, right? So we could write this in one of two ways. We could write it as 8x over 15 into 1 minus 1 over 8x. Or maybe the neater way to write it might actually be 8 over 15x minus 1 over 15 x squared, right? So now all we need to do, we write the cumulative density function. And what do we need? Well, we need three parts. The first part is what happens as we go to minus infinity. And well, that's just 0. So that'll be x is less than a. In this case, a is 0. Right? So if we go back up here and we look at the example, our value of a is 0. Right? So this is a. Then we need what happens as x goes to positive infinity. Well, by the limit definition, that will just be 1. So x is greater than b, which is in this case 3. Right? And these contributions here, you could think about them as, you see this otherwise, 0 otherwise. The otherwise are these two extremity values here. Right? So those contributions cater for the otherwise, and then our middle function, our actual meat and bones of it is just that 8 over 15x minus 1 over 15x squared. And this takes place between a and b. So this is 0 is less than or equal to x is less than or equal to 3. Right? So the reason we need these extremity values is simply because based on our definition, we know that the cumulative density function gives the value of a random variable with respect to some specific value in the range, right? So we need to see what happens at the other y's. And that's why we need these two pieces here, right? So that's the solution for the CDF, and hopefully that helps. Okay, bye.